Okay, looking at section 4 of chapter 7, graphing rational functions. Rational function is just when we have a polynomial on top and a polynomial on bottom. And so when we want to graph these, we just want to set the denominator equal to 0 and solve. So sometimes we might have to factor using CAB or factor out GCF or something like that and set them equal to 0, because those are going to find our vertical asymptotes. Okay, now sometimes if you eventually cancel out something, I cancel out a factor, that actually leaves, instead of a vertical asymptote, that will leave a hole in that spot. Okay, and we'll talk about more of that, I think, in example number 4. But vertical asymptotes set the denominator equal to 0, and you just solve for x. Now, horizontal asymptotes are when we look at the degree of the top of that polynomial and the degree of the bottom. And then when those degrees are different, then we have a couple things happen. If the degree of the top is bigger, then we have no horizontal asymptote. And when the degree of the bottom is bigger, then we have y equals 0 as our horizontal asymptote. And then if they're the same, they're the exact same, both squared or both cubed or both x's, then we take the lead coefficient of the top and divide that by the lead coefficient of the bottom. And that would be our horizontal asymptote. Y equals the lead coefficient over the lead coefficient. So here are a few examples. Here's one with no horizontal asymptote, so that's when the degrees are the same. And then here's y equals 0. That's when the denominator would be bigger. The degree of the denominator would be bigger. And here we can see we have two vertical asymptotes. And then lastly, when they're both the same, or sorry, I think I said the no horizontal asymptote is when the degree of the top is bigger. When they're the same, it's the lead coefficient over the lead coefficient. We see that y equals 2 here. Okay, and then what you just do is whenever you have your vertical asymptote, you just plug in numbers to the left and to the right of that, and you'll see kind of what the graph looks like. Okay, and then if you have more than one, then you plug in numbers to the left and to the right of each one of those to see what your graph looks like. Now you can graph this, plug this into the graphing calculator, but you need to make sure you label your asymptotes in there. Okay, because the graphing calculator is not going to show you the vertical asymptote or the horizontal asymptote as these dashed lines. So I want to make sure you know how to do that. So here we have no horizontal because we can see the degree of the top is bigger. So no horizontal one. So then we find our vertical asymptote, and that is set in the denominator equal to 0. So here we don't have to factor anything. We just solve for x. Right, so that's negative 2/3. So if I count by thirds, 1/3, 2/3, 3/3, 1/3, 2/3, 3/3, something like that. Then all I can do is just graph that. Negative 2/3 would be right here, going through that negative 2/3, and I can label that x equals negative 2/3. Now I just wanted to pick points to the left and points to the right, so I could just make a table if I don't have a graphing calculator. Okay, so I plug in negative 2, plug that in, cube it on top, and then take it plus 2/3 on bottom, so negative 2 cubed, which is negative 8, and then negative 2 plus 2/3, which is negative 4/3, so flip that and you get 6. Okay, then I can plug in other numbers, plug in negative 1, and I get 3, plug in 0, I get 0, plug in 1, I get 2/3, might have to use a calculator there, I get 0.6, and then I plug in 2 and I get 3. So I can just start graphing those. So at negative 2, I'm at 6. So maybe move this a little bit out of the way. Say this is up at 6, and then negative 1, I'm at 3, and then 0, I'm at 0, and at 1, I'm at 0.6. So maybe like there, and then at 2, I'm at 3. Okay, so you might have to put more in. I might have to put negative 1/3 in, and I see that it actually starts to kind of dip down here. We kind of go closer and closer to that asymptote because we can know we can't cross it, and then this way we know we're kind of going up. So we see that we have no horizontal asymptote, right, because we continue to go down and continue to go up. And then this one, it kind of goes back around. What's nice about one vertical asymptote is when you look at the degree of this one and your factors of this one, if you have no common factors on bottom, so none of the same factors on bottom, that means if one side goes up around the vertical asymptote, the other side will go down. Okay. And so again, you can just plug in more numbers. These ones are kind of hard because you got to plug in like fractions or decimals in here to see that this goes down and this one goes up. Okay, but you can graph it, but you need to make sure you label your asymptotes in there. Or you could use a graphing calculator, I guess, but you still need to know these vertical asymptotes and the horizontal ones.